November 1943. A German test pilot climbs into a captured American P-47 Thunderbolt. Everyone's calling it a flying milk bottle. Fat, crude, typical American junk. 90 minutes later, he lands and writes a report that predicts exactly how Germany will lose the war. His commanders read it, file it, and ignore it. 18 months later, everything he predicted comes true. This is that story. Before we get into this, grab some coffee, settle in, because this story is going to change how you think about engineering, about design philosophy, and about why Germany lost the air war. And if you haven't already, hit that subscribe button. You're going to want to see where this goes. So here's what you need to understand. By late 1943, German pilots are calling the P-47 a joke. It's heavy, it's big, it doesn't turn well. Compared to the sleek Messerschmitt 109 or the Focke-Wulfs 190, it looks like something designed by people who build trucks, not fighters. But one man, Hans-Werner Lerche, Germany's chief test pilot, is about to discover something that will shake everything he thought he knew about aircraft design. And what he learns, Germany desperately needs to hear. But nobody wants to listen. Hans-Werner Lerche was born in Breslau, started gliding as a teenager, worked his way up through sheer determination despite coming from a family with no money, no connections. When Hitler came to power and Germany started secretly rearming, opportunities opened up for talented pilots. By 1939, Lerche was a test pilot at Rechlin, the Luftwaffe's main aircraft testing facility. Unlike combat pilots who flew one or maybe two aircraft types, Lerche flew everything: new German prototypes, production aircraft, and most importantly, captured enemy planes. His logbook would eventually record over 120 different aircraft types. British, American, Soviet, French, everything the Luftwaffe could get their hands on. He was also a trained aeronautical engineer, which meant his reports weren't just "this plane flies good" or "this plane flies bad." They were detailed technical analyses. And Lerche had a reputation. When an aircraft was inadequate, he said so. When an enemy design was superior, he documented it honestly. This honesty had made him some enemies among Nazi officials who preferred optimistic assessments, who wanted to hear that German engineering was always superior, that enemy aircraft were always inferior. But Lerche's expertise was too valuable to dismiss. When an aircraft was good or bad, people listened, even if they didn't like what they heard. November 10, 1943. A P-47 Thunderbolt sits on the Rechlin tarmac. It had been captured 2 weeks earlier when its pilot, Lieutenant William Roach, got lost in bad weather during an escort mission. Low on fuel, he spotted what he thought was an airfield in southern England, landed safely, followed a ground vehicle to parking, then realized he wasn't in England. He was at a Luftwaffe base in Caen, France. German soldiers approached with weapons drawn. Roach was now a prisoner of war. His aircraft, nicknamed Beetle, was now German property. The Luftwaffe moved fast. Allied fighters were prowling the skies, strafing valuable targets. Beetle was flown inland to Rechlin before it could be destroyed. Repainted in Luftwaffe camouflage, given the code T9 plus FK, and assigned to Lerche for evaluation. Lerche had heard all the dismissive comments from other pilots. The P-47 was a joke, too heavy, too big, too American. It represented everything wrong with American design: crude, unrefined, relying on massive engines to compensate for poor aerodynamics. But Lerche had learned not to trust first impressions. He'd flown enough captured Allied aircraft to know that British and American engineers were highly competent. If they designed an aircraft this way, they had reasons. His job was to understand those reasons. As he approached Beetle, the size was immediately obvious. The radial engine was enormous. The fuselage built around it like a barrel. Landing gear thick and robust. Everything screamed heavy. German fighters were sleek, elegant, optimized for performance. This thing looked like it had been designed by shipbuilders. Lerche began his walk-around inspection and immediately noticed something. The construction quality was excellent. Clean welds, precise panel gaps, high-grade materials throughout. This wasn't crude manufacturing. This was sophisticated mass production. And there's a difference. The aircraft had been built to tolerances that German factories, increasingly stretched thin by the war, were struggling to maintain. Lerche climbed into the cockpit and immediately understood why German pilots complained. The cockpit was huge, absolutely enormous compared to the cramped confines of a Bf-109. A German pilot used to his aircraft fitting like a tight glove would feel lost in all this space. But as Lerche settled into the seat, he realized something. This wasn't a flaw. This was deliberate. In a Bf-109, you had to crouch to avoid banging your head on the canopy. The cockpit was so tight that accessing instruments was difficult. Long missions were physically exhausting. German engineering philosophy prioritized performance. If pilot comfort suffered, that was acceptable. The P-47 cockpit was comfortable. Not just adequate, genuinely comfortable. The seat was well padded, room to move, to stretch, to adjust position during long flights. The canopy was high and clear, providing excellent visibility. Everything within easy reach without straining. Then Lerche started examining the instruments, and here was something remarkable. The instrument panel used color coding. Red and green sections marked acceptable operating ranges for the engine. A pilot could monitor engine status at a glance without reading actual numbers. Lerche understood why immediately. American fighter units included pilots from multiple countries, Free French, Polish, pilots who barely spoke English. The color coding meant a pilot who couldn't read English could still operate the aircraft safely. Green meant good. Red meant danger. Universal, intuitive. It was brilliant, not from a pure engineering standpoint, but from an operational standpoint. German instruments required precise understanding of specifications and limits. The P-47 was designed so a pilot with minimal training could operate it safely. This wasn't crude engineering. This was inclusive engineering, design that acknowledged human factors. Lerche continued his inspection, and the control layout was logical. Throttle, mixture, propeller pitch, all grouped together on the left. Fuel system controls clearly labeled. Everything designed for ease of use. German fighters were designed for expert pilots. The Bf-109 was notoriously difficult to handle on takeoff and landing. Narrow landing gear made ground loops common. It took skill to master. The Luftwaffe accepted this because their training program produced skilled pilots. But Lerche knew that by late 1943, the Luftwaffe's training program was collapsing. Fuel shortages meant new pilots received minimal flight time before being thrown into combat. The elaborate training that produced expert pilots in 1939-1940 no longer existed. Germany needed aircraft that novice pilots could fly safely, but they were still building aircraft for aces. Lerche went through the pre-flight checklist. The manual was clear and comprehensive, step-by-step procedures. German manuals assumed pilot expertise. American manuals assumed pilot ignorance and explained everything in detail. He started the engine. The Pratt Whitney R-2800 double wasp roared to life. And then Lerche noticed something that would become a recurring theme. The engine ran smoothly, beautifully smoothly. He'd flown enough American aircraft to recognize this pattern. American engines were consistently smooth and reliable. German engines, particularly late in the war, were increasingly temperamental. Manufacturing quality varied between factories. Replacement parts didn't always fit properly. Engines that ran perfectly when new developed problems after minimal use. The R-2800 idled like it could run forever. No vibration, no rough spots, no concerning sounds. Just smooth, powerful operation. This was mass production at a level Germany couldn't match. Building one perfect engine in a laboratory is one thing. Building thousands of consistently reliable engines, that's something else. Lerche received clearance and taxied toward the runway. Another revelation. The P-47's landing gear was broad and robust. The tailwheel locked in place, keeping the aircraft tracking straight. Taxiing was easy. Visibility was good. The aircraft felt stable. In a Bf-109, ground handling was a constant challenge. Narrow landing gear made the aircraft unstable. Visibility over the nose was poor. Inexperienced pilots frequently ground looped during taxi or landing, damaging aircraft even without enemy action. The Luftwaffe accepted these characteristics as the price of high performance. The P-47 was designed to be operated from rough forward airfields by pilots of varying skill levels. The robust landing gear could absorb hard landings. Good ground handling meant fewer accidents. Lerche lined up on the runway and advanced the throttle. The acceleration was impressive. The massive engine pushed the heavy fighter forward with authority. Takeoff run was longer than a German fighter, but not excessively so. The aircraft lifted off smoothly. Climbing to altitude, Lerche tested handling characteristics. The P-47 was not agile in the German sense. It didn't turn tightly. It didn't have the instantaneous response of a Bf-109 or FW-190. But it was stable, predictable, solid. This was the pattern emerging. The P-47 wasn't the most agile fighter. It wasn't the fastest at low altitude. It didn't excel in traditional dogfighting. But it was competent in all areas, reliable in all systems, forgiving of pilot errors. German fighters were temperamental thoroughbreds. The P-47 was a workhorse. And Lerche was beginning to understand that in industrial warfare, workhorses win. At altitude, the P-47's turbo supercharger came into its element. The aircraft accelerated smoothly and maintained power where German fighters were gasping in thin air. Dive performance was impressive. Roll rate was excellent for an aircraft this size. Lerche flew for about 90 minutes, putting the Thunderbolt through various maneuvers. The aircraft never surprised him negatively. Everything worked as it should. The engine never faltered. Controls remained responsive. Systems remained functional. And that's when Lerche understood the deeper truth. The P-47 wasn't designed to be the ultimate fighter. It was designed to be the ultimate operational fighter. And there's a difference, a profound one. German engineers designed for peak performance. American engineers designed for sustained operations. A Bf-109 in perfect condition flown by an expert pilot might outperform a P-47 in a dogfight. But how often was a German fighter in perfect condition? How often were pilots experts? How often could mechanics perform the precise maintenance required? The P-47 was designed assuming maintenance would be performed by mechanics of varying skill levels, using parts from different production batches under field conditions, possibly under enemy fire. It was designed assuming pilots might be tired, stressed, wounded, or undertrained. It was designed assuming aircraft would take battle damage and need to keep flying. Every design decision made sense once Lerche understood this philosophy. The robust construction, the forgiving handling, the intuitive controls, the reliable engine. All of it served operational availability. Lerche returned to Rechlin and landed. The landing was straightforward, robust landing gear absorbing the touchdown smoothly. He taxied back and shut down the engine. Ground crew members gathered around, eager for his assessment. What did he think of the grotesque American fighter? Lerche climbed out and stood looking at the aircraft for a long moment. Then he said something that surprised them. "It's the best designed operational fighter I've ever flown." The mechanics looked confused. Best designed? It was huge, heavy, inelegant. How could it be well designed? It's not designed for performance. It's designed for operations. And there's a difference. That evening, Lerche sat at his desk and began writing his technical report. This was always the most important part of his job. Flying the aircraft was one thing. Understanding what it meant strategically, that was another. He organized his report into sections: performance, handling, systems, and strategic assessment. In the performance section, he documented facts objectively: fast at altitude, slow at low altitude, excellent dive performance, adequate but not exceptional turning, good rate of climb, outstanding high-altitude performance due to turbo supercharger. In the handling, stable, predictable characteristics, easy ground handling, forgiving flight behavior, good visibility, comfortable cockpit for long-duration missions. In the systems, color-coded instruments, intuitive control layout, robust construction, smooth, reliable engine. But it was in the strategic assessment section that Lerche wrote something prophetic, even though his report would be filed and ignored. The P-47 Thunderbolt represents a fundamentally different design philosophy from German fighters. German aircraft are optimized for peak performance and assume expert pilots and maintenance. The P-47 is optimized for operational reliability and assumes average pilots and field maintenance. This aircraft is designed to be operated in large numbers by pilots of varying skill levels. The forgiving handling means fewer accidents. The robust construction means more aircraft return from missions. The reliable engine means more uptime, less maintenance. The intuitive controls mean faster training. Most significantly, every design decision prioritizes sustained operations over peak performance. The Americans have not built the best fighter. They have built the most operational fighter. And they can produce it in numbers we cannot match. Lerche paused, considering how to phrase his conclusion. He knew it would be controversial, possibly even dangerous, but accuracy was more important than comfort. Assessment. The P-47 is not crude engineering. It is sophisticated operational engineering. Germany builds fighters for individual excellence. America builds fighters for industrial war. If the Americans can field hundreds of these aircraft flown by adequately trained pilots, our numerical and qualitative advantages will be negated through sheer operational availability. Recommendation: German fighter design philosophy must incorporate operational reliability as a primary requirement, not a secondary consideration. We cannot win an attrition war against an enemy that can keep more aircraft operational more consistently. He signed the report and submitted it through channels. Lerche's report made its way up the command structure. It was read, discussed, and ultimately filed. The conclusion was dismissed as overly pessimistic. The P-47 was still a crude American design. German fighters were superior. End of discussion. But Lerche's predictions began coming true almost immediately. By early 1944, P-47 Thunderbolts appeared over Germany in massive numbers. They escorted American bomber formations deep into the Reich, and they kept coming. Day after day, mission after mission. German fighters intercepted them, sometimes shot them down. But the next day, there were more P-47s, always more. Luftwaffe pilots reported frustration. They damaged P-47s that should have been destroyed, only to watch them fly home. They'd shoot down American pilots one day and encounter different American pilots in new P-47s the next day. The supply seemed endless. Meanwhile, German fighter production struggled. Allied bombing disrupted factories. Material shortages forced compromises. Quality control suffered as experienced workers were drafted and replaced with forced labor. Aircraft that should have been reliable developed problems. Engines failed prematurely. Systems malfunctioned. The operational availability gap widened. The Luftwaffe might have more aircraft on paper, but fewer were actually flying on any given day. American units maintained higher operational readiness rates because their aircraft were designed for it. A unit of 100 P-47s might have 85 to 90 available for operations on any given day. A German unit with 100 fighters might have 60 to 70 available for operations, with the rest grounded for maintenance, lack of parts, or fuel shortages. The multiplication was devastating. More aircraft produced times higher availability rates times better sustainability equaled overwhelming numerical superiority at the point of contact. Hans-Werner Lerche survived the war. After Germany's surrender, he was interrogated by Allied technical intelligence officers. They found his reports in German files and asked about his assessments. "You concluded that American aircraft were superior, not in performance, but in operational design. That's an unusual assessment." Lerche nodded. "It was the most important assessment. Your pilots weren't necessarily better than ours. Your aircraft weren't necessarily faster or more maneuverable, but you could keep more aircraft flying more consistently. You could train more pilots. You could sustain operations that we couldn't sustain." Was this apparent when you flew the P-47? Immediately. Every design decision made sense once I understood the philosophy. You weren't building for dogfighting supremacy. You were building for sustained operations. Did German leadership understand this? Lerche laughed bitterly. My report was filed. The assessment was that I'd been demoralized by flying enemy aircraft and had lost my objectivity. German engineering was superior. American engineering was crude. That was the official position, and any evidence to the contrary was dismissed. The lesson is timeless. In sustained conflict, reliability beats peak performance. Operational availability beats maximum capability. And design philosophy matters more than individual excellence. The P-47 wasn't the best fighter of World War II, but it might have been the best designed fighter. Because it was designed not for air shows or test flights or record-breaking. It was designed for war. And in war, the side that can keep fighting longest usually wins. If you found this story compelling, check out our video on why MG-42 gunners did not stand a chance on D-Day. It's on the screen. Click, and I'll see you there.